All right, today we are in lesson 7.4, and our learning goal is solving linear systems by multiplying first. So we've been talking about systems that we can use elimination, and the problem with this first one is if I use elimination here and I say, okay, I want to add all of these together, well, 6 and 2 is 8, and 5 and 3 is 8, and therefore nothing drops out, and our whole goal there is to get one of the variables to drop out and become 0. If I say, well, maybe I should just subtract them, well, if I subtract them, 6 minus 2 is 4, and 5 minus 3 is 2y. So again, nothing drops out. So this becomes an issue, and so one thing that I can do is I can go ahead and take one of these equations and multiply through all three of those terms first so that I can get one that would drop out. So what my eyes do is I always look for one of these that can go into this one. So 2 can go into 6, and 2 can go into 6 3 times. And so I'd probably say, okay, well, what if I multiply this whole equation by 3? And so what I'm going to do is I'm going to use like the distributive property and say 3 times 2 is 6. But then I'm also going to say, wait a minute, if that's a 6, I probably want this to be a negative 6 so that it drops out. So what I'm going to do is I'm magically going to put that negative 3 right there. And now I'm going to distribute a negative 3. So this equation right here is going to become negative 6x, and I can say either plus negative 9 or minus 9y equals negative 15. And that's one that a lot of people forget, that you have to give that negative 3 to every single term inside there. Okay? All right, so now I'm going to go back and I'm going to line those two up. I'm going to take this first equation here, and I'm going to write it right down here. So 6x plus 5y equals 19. And right below it, I'm going to put my new equation right below it. So negative 6x minus 9y equals negative 15. Now I can use elimination, and I can add these two together. So I have 6x plus negative 6x, so that drops out and becomes 0x. I'm going to add my next term, so I have positive 5 and a negative 9, so that's going to be negative 4y equals 19, and a negative 15 would be a positive 4. And from here, I just have to divide both sides by negative 4. And I get y equals negative 1. Alright, then I'm going to take my negative 1, and I'm going to plug it back into any of my equations, either this one, or this one. It doesn't really matter here what I go ahead and plug that back into. So I've got y is negative 1. I'm just going to choose the first one. So 6x plus 5 times negative 1 equals 19. I have 6x, this would be negative 5. I'm going to add 5 to both sides. So I get 6x equals 24. Divide both sides by 6, and x equals 4. Then I'm going to go back and put that into my ordered pair, which would be 4, negative 1. And then you could go ahead and you could check your solution by putting it back into here, and it should work in both of these equations. And if it doesn't, then you know that you've done something wrong. So if you want to plug it back in here, times 4 and times negative 1, that would give me 24 plus negative 5, and that does equal 19. I could plug it back in here and make that a 4, make that a negative 1. So I have 8 plus negative 3. That is 5. Therefore, they both check, so that's the correct answer. All right, so moving on to the next example. If I look at this one right here, okay, the problem with this one is the last time I said that I was looking for, this one I said 2 goes into 6. It's a factor of 6. So therefore, I was like, oh, I'm just going to multiply by 3. Problem over here is 2 doesn't go into 7 and 9 doesn't go into 12. And that makes this one quite a bit more difficult. So what I look for instead is the greatest common multiple of these two. So my eyes would probably go to this one because I can do this mentally. I might have to think about 9 times 12. So if I look at this, I say, well, what if I get both of these to go to 14? And then I'm going to go one step further and say, well, what if I want one of these to be a negative 14 and one of these to be a positive 14, and then that way they drop out. So I'm going to have to go ahead, and this time I'm going to actually have to multiply through both of these, which is quite a bit more work. All right, so I'm going to start here. I'm going to multiply this one through by a 7 so that I get 14x. but I'm going to multiply this one through by negative 2. All right, so I'm going to label these two equations so we can keep track of them. So I've got one as an A and one as a B. All right, so I'm going to take that A equation, I'm going to multiply through, so I'm going to distribute the 7 to each of those three terms. All right, so I have 14x, and I have negative 9 times 7, so 63y equals 7. And then the bottom I have negative 14x, and a negative would make it positive 24y equals, what would that be, negative 46. Let's hope I don't mess up on my simple math here. All right, so now when I do this one, I have 14 and negative 14, so those are going to drop out and become 0x. Whoops. Negative 63 and 24 is going to give me a negative 39y. And then I'm going to take 46 and subtract out 7 to give me a negative 39. And then I'm going to divide both sides by the negative 39. And so that gives me y equals a positive 1. Then again, I'm going to take that positive 1, and honestly, you can plug it into any of these equations. This was my A equation that I rewrote and my B equation here. So, I mean, I have 4 choices. I think it would be silly to use these because they're bigger numbers, so I would probably go up to wherever I saw the smallest numbers, because you guys know I'm lazy like that. So I'd probably go back up to maybe this one and plug it in here. So I have 2x minus 9 times 1 equals 1. So 2x minus 9 equals 1. I'm going to add 9 to both sides. So I get 2x equals 10, and so x equals 5. So my solution for this system should be 5, 1. All right, so last example we need to look at is going to be, well, what if they're not all nice and pretty and in standard form? Like these both were in the standard form, not slope-intercept form. So if I get something that looks more like this one, then I say, well, how am I supposed to add or subtract them? Because obviously these two here, I can't add or subtract those. So what we need to do first is get them both into the same form. And I would get them both into the standard form, which again, this is that standard form. Okay, so we're going to get into ax plus by equals c. Okay, so basically all I need to do is I need to move this 3x over to this other side. So I'm going to subtract 3x from both sides. So this equation becomes negative 3x plus 2y equals negative 9, because this dropped out here. I bring this over here. This is here. And I just moved around my order a little bit. Okay, so I'm going to take this, and I'm just going to rewrite it right here. So 4x plus 5y equals 35. Okay, so now I'm going to look at that and say, well, can I just go ahead and add or subtract it? Well, 4 and negative 3, no, that's going to give me an x. That's not going to give me 0x, it's going to give me 1x. So I cannot add them because 5 and 2 would be 7, so that's not going to help me. I can't subtract them, that's not going to help me. So now I'm going to have to look for ways to eliminate these, which 3 doesn't go into 4 and 2 doesn't go into 5. So it looks like it's going to be a lot like the last one where I'm going to have to multiply both of them through. My eyes would probably go to these because they're already opposite signs, and so I could get them both to 12. One would be a positive 12, one would be a negative 12. Some of your eyes might go to this one and you say, well, I'm going to get those to go to 10. I'll just get one to go to positive 10 and one to go to negative 10. That's fine too. It really doesn't matter. So again, my eyes are going to go to that positive negative already. So I'm probably going to multiply this through by 4, and I'm going to multiply this one through by a negative 3. Okay, so I'm going to come over here. I'm just going to keep going across my paper here. All right, so negative 3 times 4 is negative 12x. Negative 3 times 5 is negative 15y. And negative 3 times 35 is negative 105. All right, now I'm going to go to the next line. 4 times negative 3 is, oh, I'm sorry. Oh, you know what I did? I goofed, didn't I? I shouldn't have multiplied that through by a negative 3. I should have multiplied that through by a positive 3. So I'm going to change those signs real quick because this one was already negative. I just goofed. Sorry. All right, so 4 times negative 3 would be negative 12x, and plus 8y equals negative 36. Okay, now from here, because I went back and changed that, those two are going to drop out, which was my whole point a second ago. All right, so I'm going to go ahead and say that those drop out. I'm going to do 15 plus 8 and get 23y. And I'm going to take 105 and subtract 36 from it and get 69. Then I can divide both sides by 23. And y equals, let's see, 69 divided by 23, I'm going to say it's 3. Alright, now I've got to plug it back in. I have literally 4 options that I can plug it in here. In this one, this one, this one, or this one, because they're all the same equation. So if I want to plug it back into, I'm just going to plug it back into this one for no reason other than I just picked it. So 4x plus 5, I'm going to plug in this 3 here. So I plugged in my 3 for my y, and now I'm going to solve here. So 15, I'm going to subtract out 15. Looks like I get 4x equals 20, and then I'm going to divide both sides by 4, and so x equals 5. And again, if I want to plug it back in and check it, I can, because I take 4 times 5, which is 20, plus 5 times 3, which is 15, and I say, does that give me 35? Yes, it does. But I'd want to plug it into the other one too and make sure. So this is negative 3 times 5, so that would be negative 15, plus 2 times 3, which would be 6. And does 15 plus 6 equal negative 9? Yes, it does. So I just checked my answer, and my final answer is 5, 3. All right, there you go. That is how we solve linear systems by using multiplication first.